Okay, welcome back to the CBU General. Now remember yesterday on the video that we did yesterday, we looked at the polynomial functions and we did this part and this part. We remained with this part, and I say I'm gonna do this part on the next video that I'm gonna do, and I'm doing that video right now. Yeah. So now here they're saying show that x plus 1 is the factor. We did this one, and factorize complete tree, we did this one as well. So calculate the range of values of x for which, so this is what we are going to do. So we have this condition: 2x plus 8 is greater than 5x squared minus x cubed. So let me write that one. So we have a condition which is 2x plus 8 greater than 5x squared minus x cubed. Okay, and then remember we said this is a factor. After proving, we said this is a factor. After proving, they are saying show that, so we showed that this is a factor. So our factor in this case is we're saying factor is x plus 1. Okay, so we have a condition and a factor, and they're saying find the values for which this is the condition. So the range of the values that we're gonna find are the values that satisfy this condition. So that is, let's rearrange this one. So we have 2x plus 8, and then this one closest to the cosine becomes a negative, and that one becomes positive x cubed. So this is greater than 0. Okay, so now if you check this and then you check this which was given, you realize that they are just the same. So we can simply replace this with f of x. F of x is greater than 0. We're set to go here. So I've replaced f of x because f of x is this one. They're saying f of x, let f of x, this one, be a polynomial. Yeah, a polynomial. So this polynomial is actually f of x, and our factor is this one. So to do this, we are going to divide this polynomial by this using synthetic method. Let me say using synthetic. How do you write synthetic? Yes, synthetic method. Yeah. So this one equating it to 0, we are going to have x is equal to -1. So we have -1 there. Excuse me. Great. And then here you only take the variables, the coefficients. Yeah, the coefficients. So let's arrange this one in a way that a cubic function should be arranged. So starting with the one with the highest power, we have x cubed minus 5x squared plus 2x plus 8 greater than 0. So yeah, we've rearranged. So now that being done, we are going to pick the coefficients. So 1, -5, this one and that one. So we have 1 there, -5 there, 2 there, and +8. So this is positive and this is positive, and this is also positive. So now some questions at CBU, like I mentioned earlier, in the previous video, they're gonna ask you, say, divide this by this using synthetic method. They're gonna ask you to divide a certain function by a certain function using synthetic method, and this is exactly how you do it. So I said you bring this, the first number, you bring it down just like that, and then you multiply. Here, after you do that, you can multiply hard, simple stuff. So this one multiplied by this one, that is exactly -1. -5 plus -1, that is -6. This multiplied by this, that is +6. And this plus this, that is actually 8. 8 times negative 1 times 8, that is negative 1, negative 8, sorry. And then this one plus this one, you get a 0. So you have 1, negative 6, 8, and 0. So now you check, what was the highest power you had? It was 3. Reduce that highest power by negative 1. Reduce it by 1. Okay? Reduce it by 1. So if we reduce the highest power by 1, we are going to have x to the power 2. And then the second one, if it is reduced by 1, it is going to be x. You reduce by that 1, you're going to have x to the power 0, which is actually 1, so you don't put anything there, because even if we say 1 here, we're just going to get 8. So this is positive, yeah, positive. So that will be x cubed squared minus 6x plus 8. So this, what you get here, is what we call the quotient. And this, what remains here, whatever that remains here, be it a 0 or not a 0, is the remainder. Okay, just in case they ask you to say what is the quotient and the remainder of these two functions, you divide by syntactic method, just the way I've showed you, and then you pick this one, the quotient, and this one, the remainder. Okay, that being done, we are going to factorize this one. So we say factorizing the quotient, factorizing the quotient, yo. So we have x squared minus 6x plus 8. Yeah, so factorizing this one, we're gonna say product sum and factors. Remember this in high school, right? So this times this one, that is actually positive 8, and then the sum is actually negative 6. That's two factors that when you multiply, you get positive 8. You add, you get negative 6. That is negative 2 and negative 4. This times this positive. Yeah, this times this 8. This plus this negative 6. That's right. So this is x squared minus 2x minus 4x plus 8. This in between is simply negative 6, so we just replaced. Grouping that one, we're going to have x squared minus 2x negative 4x plus 8. What is common in here? You realize we've got x, so x factored out will remain with x and negative 2. What is common here? Negative 4, yeah. So negative 4 there will remain with x. You remove negative 4, will remain with x. There, yeah. Negative times negative gives you a positive. This in total gives you 2. So realize this one and this one are common, so you group them together. So x minus 2, x minus 4. This one and this one, the ones which are not common. Now remember, we said that this is our factor. This is our factor simply because in our previous video, in our previous session, we proved that x plus 1, this one, x plus 1 is a factor of a polynomial function f of x. So that is one of our factors. Having factorized this one, we have this factor and this factor, and that also is our factor. So we have these three factors. So what you do here, you equate each factor to 0. So we have x plus 1 is equal to 0, and x minus 2 is equal to 0, and x minus 4 is equal to 0 too. So here what you get is when this one crosses the equal sign, x is equal to negative 1. This is what you get. This one will be x. So this one will be, sorry, this one 1 will be x. How am I going to write this? Okay, let me just say 1 will be when positive 1 crosses the cosine to be negative, so x will be equal to negative 1. This one, x will be equal to positive 2. That one, x x will equal to positive 4. Yeah, that is an x. And then what you do here, now that having these values, you put them on a number line. So this is -1, yeah. So you have -1 there. And then you have 0 demarcating the number line. Then you have 2, and then you have 4. So if you notice something here, okay, so what is happening here is that these values have demarcated the number line on certain intervals. We have this interval, which is before -1. This is the first interval. The second interval is actually between -1 and 2. So we have the second interval, which is between -1 and 2, and we have the interval which is between 2. Now, so we have the interval which is after 4. So the next interval is actually after +4. Yeah, and we also have this interval you've seen here. This one should be this one to this one. So this one, this one, this one, this one, this one. So I think let's just deal with these three intervals. Yeah. So after you do that, you are going to test the values. Okay. We want values that will satisfy the condition f of x greater than 0, which means the values that we want are values that are greater than 0, and the values that are greater than 0 are simply positive values. Yeah, positive values. So we want positive values. So we are going to test this in we are going to test these values. Yeah, we are going to test them. So before -1, we have values a -3, -2. So what you're going to do, you're going to pick a value that is closest to before -1, a value that is closest to before -1, and that value is actually -2. So here, let me just put this one here, that value is -2. And then between this one and this one, you're going to pick a value again, a value that is closest to, so in this case we're going to pick 1. Yeah, we are going to pick 1 because we cannot pick 0. Nah, we are going to pick 1, the closest value to both. So we are going to pick the closest value to 2. Yeah, we cannot pick 0 here. No, we are going to pick 1 because 0 will make our equations unfine. So we're going to pick 1 there, and then here the value that is closest to the region after +4, that is +5, definitely +5. And then we are going to test these values. Okay, we are going to test these values. So we are going to test these values. So remember, we had our factors were these, right? Our factors were x plus 1, x minus 2, and x minus 4. Replacing this with -2, we are going to get, suppose here we had -2, that is -1, yeah? And then here, that will be -4. Here, that will be -6. So here again, you pick the value, you only pick the signs. I repeat, you only pick the signs. So negative times negative times negative, what you get is, what am I doing? Negative times negative times negative, negative times negative, positive. times negative, that gives you a negative again. So this is not what we want. The values before -1, we don't want them because they're not giving us the values that are greater than 0. They're giving us the values that are less than 0, values that are negative. Now we want values that are positive, so we are not going to pick this one. We are not going to pick this range, which is before -1. Okay, testing again, we are going to test 1. Yeah, we're going to test 1. So if we put 1 there, 1 plus 1, that is +2. So we have +1 minus 2, that is -1. So we have times -1 minus 3, that is -3. So we have another negative here. So negative times negative, that is positive, times positive, that is 2 positive. So this is one of the values that we want, is one of the range of the values of x that we want, the values that are between -1 and 2. So this, we mark this one. Yeah, we mark this. This is the range of the values that we want. Okay, and then we are going to test this one, the values that are after the +4. So this one, we are going to test again on the same as this. So here there were extra. Remember, these are our factors. This. So we have. Let me just write them clearly. So we have. Let me write here. These are our factors: 1 plus 1, x plus 1. I mean, x minus 2, and x minus 4. Okay. So what we get here, if we put +5 here, we are dealing with 5. Remember, values that are after +4, and we are taking the value that is closest to +4. That is immediate to +4. After, in regard with this range, after the +4, numbers after the +4 on the number line. So we have. So if we put 5 there, we are going to get 6, +6, of course. If we put 5 there, we're going to get +3. If we put 5 there, we're going to get +1. So positive times positive times positive, that is actually equal to positive. Again, we mark this range, this one, because we are getting the positive values. We mark this range because we are getting the positive values. So now, how do you now write the range of the x values that you want? Here is now a thing. Look at this, the inequality that we have been given. It is this one. So if you have this one or this one, this means the values that you are going to get are not part of. Okay, they are not part of the solution. So you indicate that by using this. I don't know how you call them, these brackets. Okay, the circular brackets whatsoever. But if the sign is like this, okay, if the sign is this or equal to, or this or equal to, you indicate that this means that the values that you got are part of the solution. So you put the square brackets like this, and then you put your answer here in between. Okay, so now here we are this one, which means they are not part of. Okay, the solutions that we've got, they are not part of the solutions that we want. So we are going to say the range of the values of x is equal to, open bracket, this one. This bracket means it is not part of. So we have -1 there, -1 to +2, and then union -4 or +4 to infinity. Okay, this, it means you are done. You are done.